Example 3.5 says you have an opportunity to invest $100 today and receive $120 in 2 years. What annual rate of return does this investment opportunity offer? Okay, we can see our timeline mapped out here. We've got $100 going in today. We're going to have $120 in 2 years. And the only question is, what rate of interest will allow these cash flows? Okay, so this is a little bit different look than what we've done in the previous examples where we've just been calculating either present value or future value. Now we're going to be using the same time value of money relationship where future value is equal to present value times 1 plus r, or interest rate factor, raised to the number of periods. But in this case, what we don't know is the interest rate. So let's plug in everything we do know. We do know 120 is the future value, 100 is the present value, and that's going to be multiplied times 1 plus r raised to the 2. All right, now I've got to do some work to get this, to solve for this r, to get it by itself. I'm going to start out by dividing both sides by 100. So they cancel out on the right-hand side, and on the left, I've got 120 over 100 is equal to 1 plus r squared. All right, now we've got to get this exponent out of here before we can isolate r. Now, this is one of those algebra tricks, like unless you just sit around and play with math or you continue on to more and more math classes, you may not have seen for a while. But if we've got something raised to an exponent here, we can take the root that equals that exponent of it to get rid of it. So in this case, it's raised to the 2. So if I were to take the square root of both sides, I would eliminate that 2. Now, a more generic way to do that is instead of saying the square root, I'm going to raise it to the 1/2. This is exactly the same thing as taking the square root, but this process will work if this was raised to the 2 or raised to the 3 or raised to the 4. Let's just say this were raised to the 4 instead of to the 2, then if this was raised to the 4, then I would just take the 1/4. I would raise it to the 1/4, and I'd be taking the 4th root of that value, and these would cancel out. So that's why I'm using this more generic version here. So I'm going to raise that to the 1/2. I'm going to raise this side to the 1/2. So we've got to do the same thing to both sides. And that action cancels out these exponents on the right-hand side. And so I have 120 over 100 raised to the 1/2 is equal to 1 plus r. Now I've gotten rid of those exponents. And so the last thing I have to do is just subtract 1 from both sides to get that r by itself. So those will, of course, cancel out on the right-hand side, and I'm left with 120 over 100 raised to the 1/2 minus 1 is equal to r. Right, now I can plug that into a calculator and say 120 divided by 100 equals, that's raised to the 1/2. If you're using a scientific calculator, it'd be a little more straightforward. With the BA2 plus, in order to raise it to an exponent, I have to type the y to the x key, which tells it to raise what's on the display to what I'm about to put in next. And then I'm going to open parentheses and say 1 divided by 2, close parentheses. So that's now my exponent of 0.5, which is 1/2. And then I can press equals, and it'll raise that 1.2 to the 1/2. That's equal to 1.0954. And I subtract 1, press equals, and so I get r is equal to 0.0954, or 9.54%. Okay, now, when we start talking about solving for either the interest rate or the number of periods, even with these simple cash flows in Chapter 3, sometimes it gets to be a little quicker to reach for the financial calculator. There's still value in solving it with arithmetic, with the formulas, but the calculator can move a little quicker for us. So let's go to, I've already got example 3.5 pulled up here. So now we can see the calculator inputs for the time value money keys. I'm going to start out by clearing my time value of money, as we always do, to get rid of the numbers that are stored on there from the previous problem. And then I'm just going to work left to right and put in the inputs that I know. So n is 2. I'm going to type 2 and then press the n key to store it. I over y is what I'm looking for, so I'm going to skip over that for now. Present value, and we can see the present value and the future value here. The way I've set up the examples, we've got a negative 100 for the present value and a positive 120 for the future value. Now, it doesn't matter which one of those you make negative and which you make positive, but they do have to have opposite signs, right? And I've said in previous examples that those signs, the negatives and the positives, are keeping track of the relative direction of the cash flows. And so if we think about this from, say, the perspective of the bank account, let's say the perspective of the person putting money into the bank account. So if I'm investing $100 today, right? So that $100 is coming out of my pocket and going into the investment. That's cash outflow for me, so it's a negative. When I'm going to receive $120, that cash flow is coming into me. It's an inflow. And so that is going to be a positive. The calculator needs to know that that is the relative direction of those cash flows. They are moving in opposite directions. We'll see what it does here in a second if we don't tell it those relative directions. All right, so present value is a minus 100, so we'll type in 100 plus minus to make it negative. Store it on the present value key by pressing PV. Payment is 0, so 0 payment. And then future value is 120. So I'm going to type in 120 and press the future value key. And now I've got everything in. I can press compute I over y, and I'll get that same 9.54%. And of course, that I over y key is in percentage format already. So instead of getting back 0.0954, like you will with arithmetic, it's actually going to give it back to you in percentage form, so 9.54%. Okay, now let's look at what happens if I forget to make one of these numbers a negative, either the present value or the future value. So I'm going to go back, I'm going to hit recall present value to pull that guy back up. I'm going to flip it to positive and restore it on the present value key. So now I've got a positive 100 on the present value key and a positive 120 on the future value key. And I'm going to say compute I over y. And I'm getting an error 5 message. Now that error 5 message is something you're probably going to run into quite a bit as you're learning to work with a calculator, as you're getting used to working with a calculator. Error 5 indicates a sign error. It means that something has the wrong sign attached to it, and the cash flows you enter do not make sense to the calculator. It can't make the arithmetic work with the formula that's running in the background. So anytime you get that error 5 on the calculator, you should have alarm bells going off going, oh, I've got to go look at my signs. I've got to think about the relative direction of these cash flows and go make sure that I have recorded them correctly in the calculator. So for example, on this one, I'd get that error 5 message and I go, oh yeah, one of these has got to be a cash outflow. They can't both be cash inflows. So let me go back to the present value and make it negative, and then I can compute the I over y and get the right answer back.